Wow. All right. Sorry about the 2 weeks vacation we had. I know a lot of people had a hard time getting back to doing classwork. So from here on out, what I'm going to do is we're going to have a flipped classroom, which means I got pretty much all of chapter 4 finished. I'm going to send you the rest of the videos today. And then what I want you to do is start watching the videos. So when we come to class, when I have a quick lecture, if you have any questions, we can go over it then. So watch it first, try to listen to the questions, and if you have any problems, then we could do it in class and fix it then and there. Or again, if you're trying it at home, then you could try it and just send me a message and we could work it over either Zoom face-to-face or on Remind. So what questions do you all have so far about chapter 4? Chapter 4 deals with polynomials. Let me switch my screen here. There. So chapter 4 deals with polynomial functions. The word polynomial, poly means many. Nomial means like numbers, or more precisely, terms. Good morning. So so far we talked about linear equations, like 3x plus 4 equals 0. Basically, linear equations have the form mx plus b. There are two terms. Since it has two terms, it's called a binomial. That's what we started off the class talking about. The next topic we discussed were quadratic equations. X squared plus 5x plus 6 equals 0. Quadratic equations have this form: ax squared plus bx plus c equals 0. Remember, that's called the standard form. Something smells good. How many terms in a quadratic equation? 1, 2, 3. Remember, anything separated by a plus or minus. There are 3 terms. So these are called trinomials. Now in chapter, I got to put my mask on, sorry. I'm so sorry. Sorry to scare y'all. So these are called, trying to remember. The first part of the word tells us how many terms there are. Nomials, again, means numbers or terms. So tri means 3, bi means 2. Cubic equations. Two x cubed, 3x squared, 5x plus x equals 0. Ax cubed, bx squared, cx plus d equals 0. Has that form. We see it has 4 terms. So this is called a quadratic equation, or a quadrinomial, meaning quadratic means 4 terms, and so on and so forth. Chapters 1 and 2 dealt with these. 1, 2, and 3 actually. Chapters 1, 2, and 3 dealt with quadratic and linear equations. Chapter 4 deals with everything else. We're going to solve equations that have much higher orders, degrees. These are what are called polynomials. Of degree n. N is the value of the highest exponent. So the n factor. The degree is the n. So in linear equations, what's the degree here? Yep. It's the exponent of x. So it's a we call it a first order polynomial because the power degree is 1. How about quadratic? What degree is that? The highest exponent is 2, so it's degree 2. This is called a second order polynomial. And then the cubic, the degree is 3. And it's the third order polynomial. So in general, a polynomial equation, polynomial function looks like this. A n minus 1, x n minus 1, a n minus 2, x n minus 2, dot, 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 a1, x1, plus a0. I should have pushed it to the left. Whenever you're solving these, always make sure that you have, notice the exponents, they're always in decreasing order. A sub 0 is the constant number. But A represents an integer. We're going to use it as integers. They don't have to be integers. They could be radicals. They could be imaginary numbers. They could be fractions, rational questions. They could be radicals. But we're going to look at them now as integers, numbers. So let's see what this looks like. If I tell you we have a polynomial of degree 5. So degree 5, that's our n value. We don't have anything else listed here. So this is what it looks like. Since it's a degree 5, our first exponent is 5. It's the highest exponent, the degree. The next one, remember what the formula says. Next one is n minus 1. So if n is 5, what's the next one? 4. Then the one below that, subtract another one. It's a sub 3, x to the power 3. Subtract another one. A sub 0, x sub 0. Remember though, x to the power 0 is what? Anything to the power 0 equals 1. So that's why this last term doesn't show up. There is no x in the last term. It's just a constant. It's just the a sub 0. Okay. So far, remember, you don't have to know everything about an equation. If I gave you an equation that looks like this, if I give you an equation that looks like that, what can you tell me about it just by looking at it? Very good. The degree is 4. What does that tell us? It's a quadratic, it's quadrinomial, yes. So what's the shape of a quadrinomial? How many x-intercepts can we have? How many vertex or turning points can we have? Right. So we'll have the x-intercepts are actually called solutions. We have at most 4. Turning points. Turning points are the same thing as a relative maximum or relative minimum. It's basically a vertex, one of the vertices. So the x-intercept, number of solutions, is always n. The number of turning points is how many? Let's look at this. Let's look what that means. Okay. Let's say we had a degree 2. We have 2 x-intercepts. How many vertices do we have? 1. It's called a turning point because if you think about it, coming from this way, what direction? Is it a positive, increasing, or decreasing function? It's decreasing. Once you get to this point, then as x gets bigger, it's now an increasing. So this point, the turning point, is where it changes direction. That's why it's called a vertex. That's where the slope is 0, and that's where it starts changing direction. So let's say if we had n equals 3. We have 3 x-intercepts. How many turning points? 2. Can you see a formula yet for turning points? Excellent. That's exactly what it is. The number of turning points is always n minus 1. Very good. So in our case, 4 minus 1, we'll have 3 turning points. So we see it's a 4th order equation. That means we're going to have 4 solutions, 3 turning points. What else can you tell me about just by looking at it? What's the shape of the curve? And we look at, you can just by looking at the equation, you can tell me the shape of the curve, the direction of the curve, which here we'll talk about the end behavior. Remember what those were? Remember when we talk about end behavior? Every graph has how many ends? 2. One going positive, one going negative. They're either both going in the same direction, up or down, or opposite directions. That's the only possibilities we're going to have. The shape. What defines the shape? I know it's been 2 weeks, 3 weeks since we saw each other. What defines the shape? The degree and the leading coefficient. So how does degree help us? Let me show you here. A little table. All right, so this is going to be my A, my coefficient. This is going to be my N. If N is even or n is odd. If n is even, the power is, if it's even, what does the graph look like? What's the smallest even power you know? 2. What is the square? What does the graph of x squared look like? Yeah, to you. Both ends go up. So if our leading term is positive, then our graph points up. What happens in the middle is we have to figure that out. But we know the end behavior. If n is even and a is positive, that means both ends point the same direction, up. If a is negative, then both ends point down. Whatever happens in the middle, that's another story. So we know by looking at the equation, the leading term only. If n is odd, if the degree is odd, and a is positive, it looks like this. Again, what happens in the middle, we don't know. All we know is that both ends point opposite direction. As x goes to positive infinity, it goes positive. So it's an increasing function. If n is positive, n is odd, and a is negative, it changes direction. So this little table here will help you visualize what the graph is going to look like. We at least know the end behavior. After the last intercepts, what's happening? What direction do those graphs go? So what degree equation is this? If I have this many intercepts, what degree is this polynomial? Yep. So the graph will look something like that. Let's pretend our leading coefficient was 2. So what do we know? The only thing we know about this graph by looking at this, what's going to happen at the very end? It's a fifth order equation. It's odd. If n is odd, it has this shape, opposite directions. Is your a positive or negative? So it's greater than 0. So your graph's going to look like this. All we know is that from the last point, it goes up. From the first point, it goes down. And whatever happens in the middle, happens in the middle. The way we determine that is, since we know this has to be negative, this has to be positive, if we took another number inside here, let's say -2, and plugged it in our equation, one of two things can happen. If the answer is positive, then that point will be above the x-axis. If it's negative, it'll be below. So at f at -2, we're going to plug it in there, whatever the function is. And if positive, above the x-axis, if that value is negative, then it's below the x-axis. We do that to any point between each of our intercepts. Bless you. So we're going to think something like this happens. When would it just touch the x-axis? We talked about that a couple weeks ago. What's the degree of this polynomial? You sure? Look at the table. Is 2 odd or even? So if it's even, it has to have this shape. So it has to, yeah, this one has to be 3 because they have to go opposite directions. And if I just lowered the x, if I put it there, the most it can cross it is 3 times. So it's this one is x cubed. But why does it bounce? Let's say it's -3 and that's 1. Why does it just bounce there? Why does it touch it and bounce back down? It touches the x-axis, but what makes it just touch the x-axis? Since we know the 0 is at -3, right? So if we solve this, we add 3 to both sides, x plus 3 is equal to 0. So this is one of our factors. If it just touches, then we have an even power on that answer. This is called the multiplicity. At this point here, so remember, it's a third order equation. It's a degree 3. So we have to 3 answers. There's 1 that's distinct, but this one here bounces, so that means we're missing 2 answers. This is where they come from. This multiplicity says how many times this answer happens. So the answer is -3, -3. And the second time here, when x equals 1, if I solve that, I get x minus 1 equals 0. So that's my other factor. X minus 1. Since it crosses, that power is 1. That multiplicity is 1. So if it's even, it bounces. If it's odd, it crosses. If you add the multiplicities, you get the degree of the equation. So the sum of the multiplicities equals the degree of the equation. So the sum of the multiplicities equals the degree of the equation. Again, all of this that we're looking at talking about now all happens from one term of that equation. So this is what our polynomial looks like. Everything that we just discussed happens here. The leading term. The leading term, because it has the highest exponent, carries the most weight. It dictates most of what's going to happen to that graph, to that function. The only other thing, so leading term is an xn. That's what we look at. The an xn is called the leading coefficient. It tells us the direction and shape of the graph. So the number in front of the x tells us if it's negative, it opens down. If it's positive, it opens up. If it's greater than 1, it gets skinnier and taller. If it's less than 1, between 1 and 0, then it gets squashed. So if the value of that is greater than 1, it gets higher. Because whatever the value of x is, we multiply it by that coefficient. Whatever the value of x is, we multiply by that coefficient. If a is between 0 and 1, then it gets squashed and lengthened. So all this stuff, just by looking at the leading term, you can tell me a lot about the equation. One more thing you can tell me by looking at the equation. One more thing. What else can you tell me? This is a constant. There's no x there. So since it's the constant, it tells me it's the y-intercept. So once we look at that equation, the value at the very end tells us, hey, that's where it crosses the y-axis. So we'll know what part of the graph goes with it. Okay, now, how many x-intercepts can you have here? At most 4 solutions. Why is it at most 4 solutions? The first one, the graph can look like this. There's 1 solution, 2 solution, 3, 4 solutions. The equation can look like this. One, two, 3 solutions. Two solutions. One solution. No solutions. So whatever the degree is, that's the most you can have. The least you can have, in this case, is 0. So most equals 4 solutions. Least equals 0 solutions. The same logic. Tell me about this graph. What's the most? What's the least? Most is 5. Very good. Least? So if it's 5, 1, 2, 3, 4, 5. It's an odd exponent, so both ends have to point in different directions, right? So we can have 5 solutions. We can have 4 solutions. We can have 3 solutions. We can have 2 solutions. We can have 1 solution. That's it. The smallest you can have is 1 solution here. Why? Exactly. Exactly. So least is 1 solution. Because they're going opposite directions. One side has to hit the x-axis. So you'll have, whenever if the degree is even, at most, at least. If the degree is even, the most you can have is n. The least you can have is 0, because they both point the same direction. If it's odd, n is the most, 1 is the least, because they point opposite directions. Very good. So just by looking at the equation, we have a rough idea how many solutions we're going to have. Let's see what else I'll talk about. Yeah. Oh, okay, yeah. There's a bunch of words I want you to know. So looking at a polynomial p of x. We can identify the degree, that's the largest exponent, the leading term, that's the term with the highest exponent, the leading coefficient, that's the coefficient of the x term, of the leading term, the highest exponent. We can find the y-intercept. Maximum number of solutions. So that's just by looking at it. In this chapter, now we're going to examine ways to determine the x-intercepts. What part of the graph is above or below the x-axis? The domain and range of the equation. That's it for it now. So that's what this chapter is all about. Because when we had equations like this, solve that one for me. What kind of equation is this? It's quadratic because it's degree 2. So what's the graph going to look like? Pointing up or down? Why? Because the coefficient of x is positive. Yeah. Because there's a 1, and 1 is greater than 0. So since it's that, the graph will look like this. So are we going to have a maximum or minimum? Yeah, since we have the lowest point here, we're going to have minimum. So what's the procedure for solving quadratic equations or polynomials? What does it have to equal? Yep. So we have to move this value over there. So we subtract 5x from both sides. So minus 5x plus 6 equals 0. Let's see if we can factor it. Because if we can't factor it, then we could either use the complete the square or the quadratic formula to solve it. So what goes in the first spot? Yeah, because it has to equal x squared, we use the middle terms. So it has to be x and x. That equal x squared. What signs go in there? Nope. So first off, look at the first term. For the signs, you look at the second sign. The only way that this number times this number can equal positive is if what? They're both the same signs. Because negative times negative is positive, and so is positive times positive. So in this case, now we look at the first term. Because that's negative, this tells us both signs are the same, that both are negative. That's what it tells us. The second sign tells us both are the same. They are negatives. Now the number. What times what is 6? When you add them, you get 5. What times what is 6? When you add them, you get 5. So the only possibilities is 6 times 1 is 6. But when I add them, I get 7. Another possibility, 3 times 2 is 6. 3 plus 2 is 5. That's what I want. So the numbers that go inside here are 3 and 2. Are we done? No. And because there's an equal sign, we're not done until x equals a number. So we take both of these answers and set them equal to 0. On the left one, I add 3. On the right one, I add 2. And eventually you'll see that at this point here, it's always the opposite sign of what's inside the parentheses. So those are your solutions. So if we graphed it, we know we have intercepts at 2 and 3. What about the end behavior? What direction does the graph go after the last points? What's the shape of the equation? Yeah, since the degree is 2, it's a U, either a U or an N. If A is positive, A is negative. Since A is positive, we know that both ends point up. That means we have a lower point here, a minimum, which is our vertex. All right, let's look at bigger ones. Polynomial x cubed plus x squared minus 17x plus 15. So what can you tell me about this? The degree is 3. So what does that mean? Okay, yes, it is a cubic function. What does it tell me about the graph? Opposite ends. It's either going to be like this or like this. This, if it's this one, if its leading term is positive. It's this one if the leading term is negative, because as x goes to infinity, this one goes to negative. Since if it's positive, it goes to positive. Since A is 1, positive 1, we know our graph will look like this. What's the y-intercept? Yep. The y-intercept is always the constant. Remember the rules of how to find the y-intercept? Set x equal to 0, and whatever your constant is, that's your y-intercept. Are 2 and -5 solutions. Are 2 and -5, are they solutions? How would you figure that out? Okay, plug them in. If they're solutions, what should happen? What's another name for solutions? Yep, x-intercepts. The location of an x-intercept is the x value, comma what? 0. If it crosses the x-axis, there is no y value. So if it's a solution, plug these numbers in there. If it comes out to be a 0, then it's a solution. So we have our equation is this. X cubed plus x squared minus 17x plus 15. That's our polynomial. Okay, the first one, I'm gonna see if it works. So anywhere I see an x, I put a 2. So it's 2 cubed plus 2 squared minus 17 times 2 plus 15. And work it out. 2 times 2 times 2 is 8. 2 squared, 2 times 2 is 4. Negative times positive is a negative. 17 times 2 is 34. Plus 15. Eight plus 4 is 12. 12 plus 15, they're both positive, so it's 27. Is it going to be 0? Since 34 is bigger, it's negative. 34 minus 27 is negative 7. So P of 2, or x equals 2, is not a solution. Try negative 5. Same function. Try negative 5. For the first one, negative 5 cubed. Is the answer going to be positive or negative? Negative, yeah, because the power is odd. So no, the answer is going to be negative. So 5 cubed. 5 times 5 is 25. 25 times 5 is 125. Negative 5 squared, it's going to be positive. 5 squared is 25. Negative times negative is a positive. 17 times 5, 85. 7 times 5 is 35. 5 times 1 is 5, plus 3 is 8. Plus 15. Since that was negative, we can go ahead and add up all of these and see if it equals 125. $85 plus 25 is 110. 110 plus 115 is 125. Same numbers, different signs, equals 0. So 5 is a solution of the polynomial. Pretty straightforward. But now, let's see what that means. So we know that 5 is a solution. What else does it tell us? Since 5 is that's the X-intercept, right? So that's what it tells us. But it tells us one more thing. Since X equals 5 is a solution, it tells us that X plus 5, X minus 5, is a factor of P of X. Since X equals 5 is a solution, I mean, it's a 0, it's an intercept. That tells us that X minus 5 is a factor of the polynomial. Because we know that X equals 5. Subtract 5 from both sides because we want it to be equal to 0. So that means X minus 5 is equal to 0. That means that's one of the factors of our polynomial. So if we can find the zeros, what numbers make them zeros, we can work backwards and create the polynomial. Find the zeros of polynomials. I should say finding. How did I get that? Finding the zeros of polynomials. So what are my zeros? I take each of these and set them equal to 0. And I add 2, so x is equal to 2, x equals to 2, x equals to 2, and x equals -1. So my zeros are -1 and 2. Those are my x-intercepts. Those are my zeros. We can graph this. If we look at this equation, how many x minus 2's do we have? So we have 3 of them. And then we have 1x plus 1. And what's the exponent of this one? How many times does it occur? Once. These numbers, these exponents, are what are called multiplicity. The multiplicity is simply the exponent of the factored form. It tells us how many times the answer occurs. It does a little bit more too. If we add our multiplicities, so 3 plus 1 equals, it tells us the degree of the polynomial. So the sum of your degrees equals the degree of your polynomial. Now, about multiplicities, they tell us a lot more than just how many times we have the answer. Multiplicities. They can be either even or odd. If a multiplicity is even, our graph bounces at that point. If the multiplicity is even, the graph does not cross the x-axis. It simply bounces off of it at that point. If it's odd, our graph crosses at that point. If the multiplicity is even, at that point, the graph will bounce off the x-axis. If it's odd, it'll cross through. So if we look at this equation we have here, what's the graph going to do at both of these x-intercepts? Well, let's see. Let's write this one down. So we have P of x equals 5x minus 2, x minus 2, x minus 2, x plus 1. We have 3x minus 2's. And we only have 1x plus 1. And we know the x-intercepts. So use this table here to help you when you draw graphs. So the x-intercepts, we have -1 and 2. Those are my x-intercepts. What are the multiplicities? The multiplicity of 2, it occurs 3 times. And -1 only happens once. So if it's odd, it crosses and crosses again. So at -1, what's the degree of a polynomial? Yep, because if we add the multiplicities, we have the degree. What's our leading coefficient? Five, yeah. Whatever's out front. It's positive. So what's our graph going to look like? The degree is 4. And the leading coefficient is positive. What's the graph going to look like? Yeah. Since it's degree 4, both endpoints have to point the same direction. Since A is positive, they both point up. And we know at -1 and 2, the graph crosses. Do we know the y-intercept? To find the y-intercept, multiply all the numbers. 5, -2, -2, -2, +1. So 5 times 2 is 10, times 2 is 20, times 2 is 40. Is it positive or negative? There's 1, 2, 3 negatives, so the answer is -40. So we know our graph crosses at -40. It looks something like that, some weird shape. But we do know it crosses the y-axis, or yeah, the y-axis at -40. All right, let's try another one. Actually, let's try this one. Tell me the zeros, and their multiplicities. So if we factor it, what do we get? Excellent. So it says they're both the same signs, they're both minus. What times what is 2 when you add them? What times 2 is 4? When you add them, you get 4? 2. So since there's 2 of them, our multiplicity is 2. Our 0 is at 2. So we have intercept at 2, a 0. And since the multiplicity is 2, what happens at that point? It bounces. Because it's a quadratic equation, has to open up. Our coefficient's positive. And since it's quadratic, both ends have to point in the same direction. So all it does is touch that one. It bounces off of it. That's the purpose of multiplicities. All right. Let's look at another one. Sketch this graph. Sketch that graph. So tell me also the zeros and their multiplicities and what's going to happen at the graph. So what are my zeros? What are the multiplicities? They're both 2. The equation can be rewritten this way. X minus 1 squared, x plus 2 squared. So the multiplicity. So what happens on the graph at those points? They bounce. So what's the degree? Yeah. Add the multiplicities. We know the degree is 4. If the degree is 4, what's the shape of it? End behavior? Right. Since 4 is even, both ends point in the same direction. Since the degree is even, that means both ends point the same direction. Do they point up or down? Why? Right. Because the leading coefficient is negative, our graph looks like this. So at -2, we have a dot, and at 1, we have a dot. So from the dots, both ends point down. And at those points, it bounces. So it looks like, what's our x-intercept or our y-intercept? The y-intercept, we have a -1, a -1, +2, and there's a negative out front. Because we have 2 -1s, we have 2 +2s, that's multiplicities, and we have a negative in front. So 2 of our answers are -1s, 2 of our answers are +2 or -2. So I'm sorry, it's gonna be +1, negative. Yeah. Since we have 3 negatives, the answer would be negative. 1 times 1 is 1, times 2 is 2. So our y-intercept is at -4. Solve that one for me. Sketch the graph. Roughly, don't have to be exact. I just want to see the points you find. Answer all those that you can. So how are you going to solve this problem? Do we know yet? What's the degree? Yeah, the degree is 4. It's the highest exponent. What's a sub n? What's the leading coefficient? What's in front of the x to the 4th? 1. Do we know the y-intercept? Negative 45. That's that entire number. The x-intercept and zeros are the same thing. We can't tell the multiplicities until we find those. Can we tell the domain? The domain of any function, any polynomial, has to be negative to positive infinity. The range, we don't know until we get a final graph of it. So what method are you using to solve this one? What kind of equation is it? It's quadratic in form. What does that mean? Quadratic in form, ax squared bx plus c. Only has 3 terms, check. The middle term, exponent of the middle term, times 2 equals the exponent of the first term. So 2 times 2 equals 4. So it's quadratic in form. So we can try to factor it. Remember, what goes in the first space is what? Whatever the middle term is. It's going to be x squared. How about the signs? Well, the second sign's negative. The only way that's true is if one's positive, one's negative. So to find the numbers, we have to find what times what equals 45. When we subtract them, we get 4 with the middle term. What times what's 45? When you subtract them, you get 4. 9 times 5 is 45. 9 minus 5 is 4. So it's 9 and 5. Where does the 9 go? Yeah, because this is plus, the bigger number gets the plus. Now what do you do? Exactly. Now we take both of these equations and set them equal to 0. Now we solve them. Subtract 9 from both sides. X squared equals negative 9. Get rid of the square with the square root both sides. X equals plus or minus. There's a negative inside there, so it's an I. The square root of 9 is 3. So there are your first two answers. The first two zeros are positive 3i, negative 3i. How many are we supposed to have? What's the degree? That tells us how many answers we're supposed to have. Since we have 2 here, let's figure this one. I have to figure out the next one. Solve for x. Add 5 to both sides. Square root both sides. So you have x equals plus or minus square root of 5. So these are our 4 answers. Even though these are our 4 answers, how many intercepts do we have? These are our zeros. 3i, negative 3i, radical 5, negative radical 5. Our x-intercepts are simply these guys. Why? You can't graph 3 i's. You can't graph imaginaries. You can't graph those, so there's not really x-intercepts. So radical 5, square root of 4 is 2, square root of 5 is a little bigger. So let's say it's 2.1, negative 2.1. So the x-intercepts are there, are 2.1 and negative 2.1. The y-intercept is at negative 45. It's the constant. So what's the graph going to look like? It's like a U, because it's an even exponent. So we know that both ends have to point the same direction. Because it's positive, they both have to point up. So the graph at this point has to point up, and the graph at this point has to point up. Since all of these answers only appear once, their multiplicities are all 1. The multiplicity tells us how many times the answer repeats itself. That's what it tells us. So since the multiplicity is 1, that means it crosses at those points. So it looks something like this. Again, right now, I just want to see the basic shape of it. We know the x-intercepts. We know what the graph looks like. So both ends, since it's positive and it's even, both ends point up. And we know since the 4th order, we're going to have 3 vertices. We're going to start building up how this looks later on. Any questions so far? I know it's a lot of stuff, but this is only the first section of the chapter. Section 3, 4, 5 gets bigger. If you look at, I'm gonna send out videos today. Section 4 is, I had to cut up into 3 sections because it was so big, so many moving parts. Okay. Solving quadrinomials. There's equations with 4 terms. We have ax n minus 1 n minus 2 and n minus 3. Only 4 terms. When solving equations with 4 terms, we first use the grouping method. X cubed minus 2x squared minus 9x plus 18. So we have 4 terms. The grouping method is this. Put parentheses around the first 2 terms and the second 2 terms. So x cubed minus 2x squared it has to be equal to 0 since we're solving equals 0. Now factor both parentheses. What do the first one have in common? They have 2 x's. So I have to add x squared. Since I took away 2 x's, I subtract 2. So the first one is x minus 2. I took away all the x2's there. Before you go further, check. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. That works. Now factor the second one. If there's a negative inside the second parenthesis, if the leading term is negative, always factor out that negative. So if it starts off with a negative, factor it out. So what number do they both have in common? They both have a 9. Because 9 is 9 times 1, 18 is 9 times 2. So since I factored out a -9, to find out what goes inside the parentheses, I divide both of those by -9. Since I factored out a -9 out of this, I divide by -9, see what's in there. So negatives cancel. 9 divided by 9 is 1, so it's just x. Positive divided by negative is negative. 18 divided by 9 is 2. This is what you're looking for. How many terms do we have now? This is one term. This is one term because it's separated by a minus. We only have two terms. What do they both have in common? X minus 2. They both have an x minus 2 in common. I take it out. What do I have left remaining inside there? If I took away the x minus 2's, those are gone. What am I left with? Yeah, just the coefficients, x squared minus 9. If there's nothing there, what would I pull out? 1, exactly. Good job. So once I put parentheses in both of them, factor out what I could. Now I only have two terms. I factor out what they have in common, which is x minus 2's. Whatever I have left goes inside the second parenthesis. Now what do I do? Now I solve them. X minus 2 equals 0. X squared minus 9 equals 0. Add 2 to both sides. And this one, add 9 to both sides. X squared equals 9. Square root both sides. So x equals plus or minus square root minus 3. So those are my x-intercepts. Those are my zeros. X-intercepts, zeros. What are the multiplicities? What's the multiplicity of 2? How many times does it occur? 1. How about the multiplicity of -3? It's also 1, because it only happens once. And +3, it's also 1. So what does that tell me about my graph? What's going to happen at the x-intercepts? Is the graph going to bounce or cross at that point? So my 0 is at 2, -3, and 3. Multiplicity is 1. If it's odd, if the multiplicity is odd, then the graph crosses at that point. So we know at these 3 x-intercepts, the graph's going to cross. But what do we know about the graph itself? What's the basic shape of the graph going to look like? What's the degree of the equation? The degree is 3. We'll have 3 answers, which we do, 1, 2, 3. Because the degree is odd and the leading coefficient is positive, the graph will have this basic shape. Graph's going to have that basic shape. Do we know the y-intercept? Yeah, 18. It's the constant. The y-intercept is always the constant. So we know our x-intercepts are at -3, 2, and 3. And the y-intercept is at 18. The degree is 3, and a is positive. It's 1. So the graph looks like this. Because the degree is odd, both ends have to point opposite directions. And since the leading coefficient is positive, that means the right-hand side goes up. Since the right-hand side goes up and they have to go opposite directions, that means the left-hand side has to go down. And so let's, I don't know what's going to happen there, but I do know that here it crosses and there it crosses. It'll have that basic shape. All right, here's another polynomial. 2x cubed minus 3x squared plus x plus 6. Are 2, 3, and -1 zeros of the polynomial. So P of x equals 2x cubed minus 3x squared plus x plus 6. I want you to determine if 2, 3, and -1 are zeros of the polynomial. So how are you going to do this? X equals 2, x equals 3, x equals -1. All it's telling us to do is plug in the values and work it out. Don't copy what I'm doing before. I mean, you should know it since these are zeros. We're testing as zeros. Plug them into the equation. Don't copy what I'm doing, because if you're copying what I'm doing, you're not doing anything. You're just Xeroxing. I can send you this after class. You'll get the same result. Did you get them all? Did you get them all? What'd you get for the first one? What'd you get for the number? You get 10? So the answer is no, it's not a zero. And next one. 3 cubed is 27. 3 squared is 9. 2 times 27 is 54. 9 times 3 is 27. 54 minus 27 is 27. 27 plus 3 is 30, plus 6 is 36. That's also no. Negative 1 cubed is negative 1. Negative 1 squared is positive 1. Positive and negative is a negative 1 plus 6. So it's negative 2 minus 3 minus 1 plus 6. Negative 2 minus 3 is negative 5, minus 1 is negative 6, plus 6, 0, yes. So one of our solutions we know is at negative 1. We have to find 2 more. So that's it. If I ask you, is this value as a 0 or a solution, just plug it in there and see what you get at. And be very careful, because it's easy to make a mistake on these things. Okay, solve this one and graph it for me. I shouldn't say graph it. Sketch the graph. So, what method are you use to solve this one first? So I hope you're using grouping method. Okay, here are the steps so far. Check your answer, see if you have the right steps. This is the difference of two squares. So it factors out x plus 1, x minus 1. So what are your zeros? Very good. And their multiplicities? They're all 1. Very good. So that means they all cross. The degree of the polynomial is 3. And the a is 1, which is greater than 0. So the graph will look something like this. So from the left dot, it'll go down. From the right dot, it'll go up. So at -3 and -1 and 1, those are my x-intercepts. My y-intercept is at -3. So this way it goes down, this way it goes up, and they cross through all of them. So this one has to cross. So there's the basic shape of the graph. Is it okay? Pretty good so far? Let's try one more. X cubed plus 3x squared minus 9x minus 27. So I use grouping, put parentheses in the first two and the last two, include the negative in the middle. Factor out what you can. So we have difference of two squares. See, the problem with just copying this is because next time you see it, you won't know what to do unless you see it written already. So my zeros are at -3, 3. The multiplicities are now different. -3, +3, and we have a Y-intercept at -27. We know the degree is 3. A is 1, which is positive. So that tells us, since the degree is 3 and A is positive, both ends point different directions, and to the right it goes up. So that is all I know for sure. I also know it has to cross through -27. But at -3, since the multiplicity is 2, it bounces. And at +3, multiplicity is 1, so it crosses. So it looks something like this. All right. So things are going to start changing a lot, because here we're only limiting ourselves to cubic functions that are factorable. As we start going through this chapter, we get away from that. We're going to have 5th, 6th, 7th, 8th, 15th orders equations. You have to know how to do all this stuff, because this gets really, really, really tricky now. All right, so please try to do the homework, because also watch the videos I sent out for sections 2 and 3. Because from here on out, the fastest way we can move is if you guys watch the videos first, have questions. Because other way than that, I lecture, you guys don't have any time to ask questions until the next time you meet in class. So you're already 5 days behind. So the way we're going to finish up the semester from here on out is your homework is to watch the videos, do the work, and then have questions during lectures. All right. So that does it for today. Questions?